Dear students, in this video I am going to discuss very important concept in DBMS, that is concurrency controls, types of locks and deadlocks in detail. This is a very detailed video. It will be very clear to you hopefully by the end of this video. First we will see what is concurrency control. Concurrency control means if multiple transactions are running simultaneously, that means if more than one user is online and trying to access the data or database and performing some operation, right? It should not interfere, the work of one transaction should not interfere the work with the other transactions, right? So that inconsistent data should not be shown to the users. So concurrency control, that is the main thing. So here what the database system has to do is it has to take care of these concurrency mechanisms to maintain integrity and consistency of the data. That is, database should always show the correct data, the reliable data, or the data which users have inserted should be shown to them in a proper way. Now, concurrency control we can understand by here we are having two transactions. T1 and T2 are two transactions here, right? Suppose transaction T1 transferred $50 from account A to account B. Consider a banking system where $50 is transferred from account A to account B. That is shown in T1. So to do that, first we have to access, the database system has to access the read A. Account A should be accessed from the database. That means it has to bring the value of the account A to memory. This is account A, right? So whatever amount is there, that should be minus 50 should happen. Then the changes must be saved in A, right? Then bring the account B value to the memory or the primary storage. Then add this plus 50 and save the changes. This is what we mean by transaction T1 here, right? T1 means read A and all these things are shown here. That is what I have explained. Now there is another transaction where another user T2 transfers 10% of the balance from account A to account B. So first read the value of A and bring the value of account A to the main memory or the primary storage. Then what we have to do? We have to calculate 10% from here, right? And perform reduction of this 10% and save the changes in the database. Write A means save the changes here. Then read B and bring the B account value to the primary storage. Then add this 10%, that is what we have calculated in the previous case from A, and then save the changes of B, right? So this is another transaction. Suppose these two users are online and consider that account A is having $1,000 and account 2 is having $2,000 respectively. Here we are having a schedule 1 in figure 15.3. This is schedule 1. In this case, first T1 is executed followed by T2. The first T1 is executed, then followed by T2 in this order. No issue in that, right? Even though both users are executing their task, so there will not be any issue if it is done in this way, which is a serial schedule T1 followed by T2. In another case, we have first T2 executed, then followed by T1, then also no issues, right? Even though both tasks are being executed serially, but not at the same time here. But the problem occurs when both are trying to execute at the same time. When both users are trying to do their job at the same time. Here transaction T1 is transferring $50 to A. Suppose this is the case. Here we are having T1 and here we are having T2. Now very important thing is both are executed concurrently. Concurrently means at the same time they are trying to execute. Now T1 has started, right? T1 has brought the value of A to the memory from the database. It has fetched the value of account A to memory. Now this is the step. Now 50 is deducted from A, right? But the changes are not yet written to A. Here, if you see here, changes are not yet written to A. In the meantime, T2 has started. Right. After this stage, when A1 value is decreased by 50, T2 has started and tried to access account A, read A. What T2 is trying to do? 10% we have already discussed. Remove from A and add to B. Now read the value of A, right? Read the value of A. Then what we will get here? Because it is not yet written, So it will bring 1000 here, right? Because even though 50 has been detected, it is still in the memory, right? Not yet written here. If you see, it is writing after this part. Now 10% is calculated. 10% of 1000 is how much? 100. Then 1000 minus 100. This part is executed. So now A reflects 900 value. Write A when we say at this stage by T2, transaction T2, it shows 900. Right. Now it has started read B. So read B is brought to memory. What is read B? Is shown here 2000. Now the other part is the other part is now continued of T1. So initially it has done A minus 50. Now write A. So initially what is the value of A? It is 1000. When we remove 50, it becomes 950, but it is saved here, right? This part has been saved by T1 at this stage. Now read B. What is the value of read B? 2000 here, right? Initially A is 1000 and B is 2000. So read B means 2000 here. Now 50 is added to B. Now write B means 2050. Now after this, the other part has, T2 has continued its work. So in T2, B is B plus the calculated value of 10%. So what is the value of B here? 2000. Then how much is calculated? 2100. Then how much is returned to B? 2100. Right. But here, what is the value? In the first case, what is the case of A? 950 here and 2050 is the B value. For the other transaction T2, what is the final value of A? Final value of A is 900 and the final value of B is 2100. Right. So after completing this T1 and T2 in this way, if we observe what is the last value of A, even though this A, for this one I am highlighting here, this A means 9000 here for T2. After this, there is a change in this one, right? Now this is the final value of A, 950, right? Final value of A is how much? 950 is the final value, because this is after this one, 950. Whereas in the other case, what is the value of B? Here it is 2050. 2050. After this step has been executed by T2. So now the final value of B, I will highlight in the yellow color here. It is 2100. Right. So now if you carefully observe, I put a star mark here. This is the final value of B, 2100, and the final value of A, 950. So if you add now 2100 and 950, what is the sum here? 3050. But what it should be? It is initially 1000 plus 2000. So at the end of the transaction, it should be 3000 only. But what is the database stage here? 3050. That means the database is now not in a consistent state. That means it is showing incorrect values. The database showing incorrect values. Why this happened? Because T1 and T2 are executed concurrently. T1 and T2 are executed concurrently. So database is showing incorrect values, or it is not in a consistent state. So what should be the solution? When the users are online, we have to use something known as logs, database logs. So now we see the next topic, log based protocols, right? There are two types of database logs. One is the shared log. So what is the shared log? That means if a transaction has obtained the shared log, that means it can read. It can only read. Shared means it can only read and cannot write. Cannot write means it can only read the values from the database and it cannot do any changes to the database. Cannot write means no changes can be done to the database. Read only. That is shared mode log. What about exclusive log? If a transaction has obtained the exclusive mode log, that means the transaction can read as well as write. That means if a transaction has obtained an exclusive log, that means for an account A, it can read the value, it can change the value. So shared lock means more than one transaction can use shared lock, because if there is a transaction T1, it is just reading the account A value. It can read because there is no change here. Another transaction T2 is running at the same time. It want to read. Yes, it can do. Another transaction is online, concurrent at the same time. This also want to access the value of A in the read mode. That is shared mode. Yes, that means shared mode means the multiple transaction can access the value in the shared mode because there is no change to the contents of A or account A here. Exclusive means, suppose if there is an update to the balance in the account, if there is an update to the balance, then the transaction has to obtain the exclusive mode log. That means only one transaction can obtain exclusive mode log. It cannot be used by more than one because inconsistent values may result here. So we have to understand here there are two types of, there are more than two, but basically our most common one are two types of database logs. One is the shared mode log, that is read only log. More than one transaction can access at the same time with the shared mode, reading only. Exclusive means if we want to make changes to the value of account or some account balance, then only one transaction can access that log. Until it completes, any other transaction neither can change nor can read. That we have to understand. For example, if there is a transaction T4, it has obtained an exclusive log for the account A. That means this can only change or read or write. Whereas at this time, if another transaction tried to access this one, so no, this is not allowed because exclusive log is given to T4. So exclusive is for only one, shared is for more than one. Right. Now there is compatibility matrix is a log compatibility matrix. What is that? So if there is a shared log, another shared log. Shared with shared is true. Right. If there is shared log, another one wants to access. Read only. Right. For account A, if someone is trying to read, another one trying to read, another one is trying to read. Okay, shared and shared are compatible, but shared and exclusive not compatible. False. Shared with exclusive. S for shared, X for exclusive. So shared with exclusive is not possible. If one is trying to read only, another is trying to modify, no, not possible. Exclusive with shared, also false. Exclusive with exclusive is also false. That means exclusive is only for one. Exclusive, that is the meaning of exclusive itself. Only one transaction can get, whereas shared means multiple transactions can share this database value. Right. So this is what the meaning of a log compatibility matrix between shared. Now we will see a system where transactions are happening concurrently and how these logs are obtained and whether there is any chance of deadlocks and all those things. We will try to see with a detailed example. Consider a banking system having two accounts A and B. Now we will see transaction as T3 and T4. What transaction T3 is trying to do? It wants to transfer $50 from account B to account A. Right. 50 means from account B, we want to remove minus $50 and this 50 should be added to whom? Account A. This is what transaction T3. What about transaction T4 at the same time tried to do? It just want to show the sum of balances of account A and B. Right. This is the thing. A plus B, just two things it wants to sum of A plus B. Suppose if account A is having 1000, account B is having 2000, then T4 just want the result as 3000. Right. So now you are clear with this one. We will see what is deadlock now with this example. Now these transactions are executing concurrently. Concurrently means at the same time. Concurrently means both the transactions are running at the same time. First T3 has started. Right. In T3 we want to make changes to both B and A. Right. In T3 because we are accessing the value of B account, get the value of B account, do minus 50, save B and change the value of B with minus 50. Then get a lock, exclusive lock on account A, read the value of A, then add plus 50 that is taken from B, then save the changes in A, right? Then unlock A. So once the transaction is done, it will unlock, right? So because there are write operations, so in T3 what we are saying, lock exclusive of B. Once it is done, it is saying unlock B. Because A also must be changed, 50 should be added to A. So exclusive lock should be accessed. Then A must be changed and unlock A. Whereas in case of transaction T4, because only we want to do A plus B, just display the output A plus B. That means only read the values, no need to write anything here. So lock is shared of A, get the value of A, unlock A. Then lock shared of B, just read the value of B, unlock B. Then display A plus B. These two transactions now we will show here partially how they will run concurrently at the same time. Now T3 has started, right? Lock exclusive of B. Continuing from the previous example there, lock exclusive of B, that means get the exclusive lock on the account B so that $50 should be removed and change should be done in B. Up to this part it has executed. That means change is done in B. Now what we have to do? Change must be done with A to add plus 50. So to do that, it should get an exclusive lock on A because it should change A. But before that, the transaction T4 has started and it continues, and database system shifted to T4 and the transaction. Database system has shifted to T4, and what is the job of T4? Just A plus B, display the total A plus B. That means only shared locks are needed here. So T4 has requested for shared lock, it obtained the shared lock, right? Now it has requested for shared lock. This is the request for shared lock on B so that it can get the value of B. Whereas if you see the other side, A has been changed. To make changes in B, transaction T3 has requested for exclusive lock of A, right? At the same time, what is happening in the other side by another user? Another user has already locked A. Now T3 wants this exclusive lock on A, whereas the other case, T4 wants now shared lock on B. T4 wants shared lock on B, but it is already locked by T3, right? That means we have arrived at a state where neither of these transactions can ever proceed with its normal execution. Why? Because T3 is waiting for T4 to release a lock, right? Here if you see what T3 is requested, it needs a shared lock on B, but it is already locked by T3, exclusive lock by T3, so it cannot get. Whereas T3 is requesting exclusive, but there is already a lock done by T4 on A, right? So T3 is waiting for T4 to release a lock and T4 is waiting for T3 to release a lock. So neither of these transactions can proceed further. So this situation is called deadlock. So deadlocks are bad for the database performance because system cannot proceed now. So what is the solution here? When deadlock occurs, database system detects this deadlock actually. After some time, it on a routine way, it keeps on checking whether any transactions are causing like these deadlocks. So it will check that if there is any deadlock, it must roll back one of the two transactions. Either T3 must be undone, which is partially completed, or T4 must be undone. Only one can proceed, right? Because once it is undone, once it is rolled back or undone, what it will do? It will release the locks. It will release the locks held by the transaction so that another transaction can proceed, right? So this situation is called deadlock, where both transactions are waiting for each other to unlock the things. So now finally what we see, reasons for deadlock. Coding long transaction. If we have a very long transaction, for example, transaction is but a code, a piece of code. If there is lengthy, very long transaction where it needs multiple locks, where it needs multiple locks, right? Long transaction are most common cause of deadlocks and blocking, because many locks are needed, many locks are when it needs many locks. So once it starts and it tries to access a lock, but that is held by another transaction, so it will wait here at this stage, right? So long transaction means more locks needed, so there is chance that deadlock may occur. Another thing is restrictive explicit lock. That means each transaction should lock all its data item before it begins the execution. So what is the solution of deadlock is also given here. Long transaction coding is one of the main reasons for deadlock. We have to keep the transaction short. That is the solution. Don't make a very long transaction so that locks and unlocks happen quickly or fast. In case of the second one, restrictive explicit lock means before a transaction, suppose if a transaction T1 is this much lengthy, so it needs maybe 5 locks on 5 items, account A, account B, account C, like this. First it should obtain all the locks, then only it should proceed, right? That means after entering the transaction, or once the transaction is partially executed and it tries to access the grant of a lock in the middle of the transaction, then it may not be possible, because some other transaction might have access that one with another type of lock. So before entering a long transaction, first it should get the access or permission of all locks, then only it should continue with the execution of the long transaction. So this is about the reasons of deadlock and the solution are given. Hope the video is clear, though it is somewhat lengthy. If you have any doubts, do write in the comment section. Do like, subscribe and share this channel. Thanks for watching.